So this is our bell work. We've got to simplify this expression. This is not an equation where we're going to be using principles of equality because there is no equal sign. So looks like we got x terms and constants on these, which means in the end we should only end up with 2 terms in the expression. Now, the reason why we're seeing this, just like we've seen it before, I think it was Unit 3, is that we're going to be solving equations that have this kind of thing in it, okay? So what that means is that we'll expect it to equal something like, I don't know, 5. And then we would solve it using this process, okay? This one's not, of course, so we're just going to focus on simplifying this, just like we will be doing when we solve equations that have this type of expression on one side of the equation, the equal sign, okay? So to start out here, I'm going to distribute this -9 into the parentheses, okay? Now, for some of you, it's beneficial to see that as 1x, it's a phantom 1. So it's really -9 times 1x's, which would be -9x's there. And then you also have, again, this is a -9 because the minus sign to its left, so it's -9 times -4, which makes that a positive 36. Okay, so the new expression, just with this small amount of simplification, becomes 30 minus 10x minus 9x plus 36. So now we got 4 terms, but there's only 2 different types of terms. We got constants and we got x terms. Now the first term I see is the 30, that's a constant, so I'm going to look to combine it with the 36. And I know that 30 plus 36 is 66. If you didn't know that, put it in the calculator and it will know it for you, and that's okay. All right, on the other hand, we got the x terms, right? So I'm looking to see how many x's this would be. Well, that's -10x's and -9x's. It really comes out as -10 minus 9, which then comes out as -19x's. So there's our 2 terms that we need on this one, 66 minus 19x. Of course, some of you like to switch that up and make it -19x and plus or positive 66. It's the same thing, just in a different order. Okay, and it doesn't matter which one of these you would use, you'd get the answer correct either way. All right, for those of you that remember, not that many people do because it's school, but we've seen this objective before. I can simplify expressions with distribution, which is multiplication, and combining like terms, okay? And by the way, we did see both of these on the bell work. So as long as you remember how to do that stuff, and it wasn't meant to be hard, just kind of as a review, and that's pretty much what this whole lesson is. It's a review of distribution and combining like terms, which we have seen not only once, but probably many times by this time, okay? So as a quick review as well, variables, remember variables are usually represented with letters. They represent unknown values, which means that you could replace the letters with numbers as long as they maintain truthfulness, okay? Especially when it comes to equations. Now, in word problems, it'd be nice to define those, which we've seen. But do understand that once we start seeing 2 variables in equations, they can represent many values together. That may not make a lot of sense now, but I hope it will when we go over that kind of stuff. Then we have terms, like terms, coefficients, and constants. So a term is just a part of a math expression or sentence that's separated by addition or subtraction. Okay, so in this expression right here, this is the bell work. We got 30. That's one term because it's separated by this minus sign. We got the 10x, which is negative because of the minus sign to its left. And then this is, by the way, its own individual term, -9 times x minus 4. This is an entire term. Okay, now you may say, well, there's some subtraction in the term. That's true. But it's being combined with this multiplication, which is why it becomes its own term. That'll be very crucial for those of you guys that want to take calculus, which right now maybe that's not the case, but in the future perhaps. Not that you'll remember this anyways. But in any case, you got like terms, which we talked about. After simplifying this, we had some like terms from the distribution. But as of this point, there really is no like terms to combine, okay? But the nice thing about like terms is that you can combine them. Now, for the most part, we're just going to be dealing with x-type terms, like you see right here with this -10x, and then constant terms, which is kind of like that 30 right there. And then, like I said, after the distribution, you had an x term and a constant as well. We've been using the word coefficient, and I think not only right now because of the holiday break that you guys have forgotten what a coefficient is, but a lot of people forget because it's just not a word you use very often in everyday life. But a coefficient is a number being multiplied by a letter, a variable. Okay, so if you looked at this expression right here, let's look at this term right here. Let's just focus on that negative 10x right there. If we asked for the coefficient of this term, it would be negative 10. Just negative 10. It doesn't include the x. The x is a variable. That's a different classification. The negative 10 is considered the coefficient. So, sometimes you'll see this where it's just an x. Remember, that makes the coefficient what we call a phantom 1. It's there. You just can't see it. So it's lurking in the shadows, always watching. And as scary as math is, that kind of makes it more creepy. But constants just numbers by themselves, like the 30 right there. If you saw a number by itself in a math expression like this one, that is considered a constant. Okay? So here's a nice expression that we must now simplify. 3x's minus 19x's. By the way, these are both like terms, and yes, it is a 3x and also a negative 19x. So when we combine these, we should have a different number of x's, but it'll only be one term because there's only one type of term in this expression, x's and x's. So that would be like taking 3 and minus 19. 3 minus 19 is negative 16. Negative 16 x's. That's how many x's we end up with on this one, okay? Is it okay that they're negative? Yeah, it is. It's okay if your coefficient is negative. And what is the coefficient here? It's negative 16. What's the variable? X. How many terms are there? There's just one right here. There was 2 in the beginning, but they were both like terms. Okay, so there's all the vocabulary right there too. And you guys try this one out. 8 plus x minus 1 plus x. 30 seconds, go. So we got this expression, and again, there's only 2 types of terms. You got the constant 8 and negative 1, and then you got an x term here and an x term there. Now, we can't see those coefficients, but that means that they are phantom 1s. They're there, you just couldn't see them, that's all. Now, it doesn't matter which one you choose to combine. I like to start from left and go right. So I'm going to start with the 8, the constant. Is there another constant that I can combine the 8 with? Yeah, it's a negative 1. It just comes out as 8 minus 1, which is 7. Then I have the x terms. You got one x there and another x there. How many x's will that be? Well, 1 plus 1 is 2 for now. So we end up with 7 plus 2x. And like I said, if you had started with the x terms, you may have written it in a different order. It still is the same answer, though. But that's a positive 2x there and also a positive 7. So you end up with 2x plus 7. Either one of these will work. So here's a big one. No problem, though. Again, there's only 2 different types of terms here. You got the x terms, here, here, and here. And you got constants, 5, negative 22, and 4. Now, like I said, I like to start from the left. So I'm going to start with the x terms. You got negative 4x's, 18x's, and negative 65x's. They're all x's. So you got negative 4 of them, positive 18 of them, and also negative 65 of them. That's just going to read as negative 4 plus 18 minus 65. And I'm just putting that in my calculator. You're welcome to do that in your head or on paper if you'd like, but the calculator knows what that is pretty quick. I typed it in. I got negative 51 x's. Okay? That's how many x's result by combining all of these x terms, these like terms, which are x terms. Now we got the constants, 5, negative 22, and 4. So 5, negative 22, and positive 4. When I combine these, I get negative 13, it looks like. In fact, I'll write that a little bit better. Negative 13 there. Now again, if you had changed the order, it would have been okay, as long as the terms keep their signs. So the 13 has to be negative, negative 13. And then the 51x also needs to be negative. It just reads as minus in between there, that's all. So that, either one of these would do as our simplified form of the original expression. And once again, we expected there to be 2 terms in this. We've got an x term and a constant because there were only x terms and constants in the original expression. Okay, and I can't emphasize this enough. Remember, we're going to be seeing this in equation format, right? So right now, there's no equal sign in this expression. Eventually, there will be an equal sign right here, maybe some stuff over there. maybe even some distribution, who knows, we'll see. But when we do see them, we're gonna call them multi-step equations because we've seen where it takes one principle of equality to solve equations and then two as well. Now we're gonna start seeing lots of different strategies combined, such as combining like terms, which we just saw on those last three problems, and the bell work, and now the distributive property, which we saw in the bell work as well. Now distribution is usually shown with this double rainbow business like this one. And yes, if you YouTube it, double rainbow's been known to make full-grown adults cry. Whatever. In any case, it is multiplication. Remember that distribution is multiplication. So why is it multiplication? It's because in between the A and the parentheses right here, there's a multiplication sign. But multiplication is the only operation that is not always shown. As you can see, even between the A and B here, there's multiplication, and also between the A and C as well. Those are multiplication because we're taking the A on the outside and multiplying it by all the terms on the inside. It is possible for this to end up being distributed into three terms as well. So you can have something like this one, and then you can distribute the A to all three of the terms, which then becomes A times B plus A times C plus A times D, okay? Now, it's not, we don't usually show it with this type of format, right? Like we would just drop that and say AB plus AC plus AD. Now, of course, we would evaluate these multiplications, just like we did on the bell work, but we tend to work downwards instead of to the right, as you see here. But this is just how the property works. So for this one, okay? Now, in the beginning here, we got 11, two terms, 11, and then this negative x plus 6 quantity, okay? And really what I'm doing in the beginning here is I'm just gonna ignore that 11. I'm ignoring it completely. Why am I ignoring it? Because I have to do the distribution first. Why must I do the distribution first? Because of the order of operations. If we get rid of this, let's see if technology, there it is. In between the 11 and this parentheses is this minus sign, okay? Now between the minus sign and parentheses there's multiplication, and the order of operations says you must do the multiplication before you do the subtraction. So that's why right now we're just ignoring that 11, okay? Now the problem here that we encounter with students is they say, I don't know what the crap I'm distributing here, right? Well, that's because you just can't see it. If you could see it, then you would know, and it's just a phantom 1. Remember those creepy phantom values like 1? This is it. When you multiply, you don't have to see ones being multiplied. In fact, even beyond this, there's multiplied by ones all over the place right here. It's just you can't see them, okay? And we don't really want to see them, so I'm not going to show them. But I do want to see this one that I'm distributing. And in fact, it's not even a 1 that I'm distributing, it's negative 1, okay? Because of the minus sign in the front. So I would say 1, and then I want to show that x coefficient of 1 there too. So I'd have negative 1 times 1x's, which would be negative 1x's. But also I have negative 1, and that's a positive 6 because of the plus sign. Negative 1 times 6 is negative 6. Okay, now this is what I get in red just from the distribution. But now, let's move this, and we can see that in the beginning there was the 11 as well. So we got the 11 that I can combine with its like term, the constant negative 6. So I will. 11 minus 6, really, which is 5. And then this negative 1x, I just drop it. And yeah, again, I'll show it in its other format because some of you may have written it that way. It would be negative 1x and also positive 5. So plus 5 right here, okay? Either one of these will do because they are exactly the same thing, just shown in a different way, that's all. Well, you guys take a minute and try this one out then. Negative 7 minus 4 quantity, 5 times 5n minus 1, and then plus 8. 1 minute. All right, let's see how you guys did. If you're still working, do finish, then just check what you get with what we end up with, okay? So we do see some distribution right here with the parentheses, okay? And remember, it's multiplication. This, by the way, is negative 4 because the minus sign is immediately to its left. Okay, so it becomes a negative 4, and we need to distribute. Negative 4, let's be negative 4 groups of 5 n's. That's going to result in negative 20 n's. Yeah, so the letters changed, by the way, but that doesn't matter to us. It could have been an X, it could have been an A, doesn't matter. And then we also have to distribute the -4 into the -1 there. So remember, distribution is multiplication, so it's -4 times -1. And if you're doing that in your head and you find that you're making mistakes, just put in the calculator, and that should show you that it's a +4 right there, okay? So now looking at the rest of this stuff, we didn't do anything with the -7 end, so it just kind of drops right there, and same with the +8 at the end. So our new expression no longer has any distribution that is necessary for us, which means that all we're looking at now is addition and subtraction, and we do have some like terms to combine. I got the end terms here. Well, how many ends would that be? It'd be -7 ends minus 20, which results in -27 ends. But we also have the constants 4 and then +8, which would, 4 plus 8 there is 12. Now again, we don't just write it as 12. Since they're not like terms, we got to keep them separated. So the 12, I would show it's positive with this plus sign, okay? And yeah, again, you could have switched the order here, making the 12 the first term, and then the -27n the second term. It's the same thing. Again, the order's just changed. But either one of these would be correct. Next up, we got equations. Yes, we can use the distributive property and combining like terms in equations. In fact, if we see any distribution or need for combining like terms, then we will. Once we get those done, once we get all distribution taken care of and all combining like terms taken care of, we will look to use principles of equality to solve the equation. But we have to get distribution and combining like terms done first, or we generally do, okay? So here we go. Now we got this expression. It's not an expression, it's an equation now because it's got the equal sign, okay? So we're going to solve this equation for x. Now, what this means is that we got the equal sign, and that's an important part to remember. Okay, where is the equal sign? I found it. It's right here. On the right side, it's just a number, so there's nothing to really combine with the 47. It's just going to equal 47 no matter what right now, okay? We're not really dealing with that 47. But on the left side, there's lots of stuff to deal with, such as the distribution. Right, we got the 4 times this 3x plus 1, so I'm going to distribute it. And yes, that's a +4. So it's really 4 groups of 3x's, which would give us then 12x's. That's positive, by the way. And then with the second distribution, which is multiplication, that's 4 times 1, which is +4. Now, just like we saw in that last problem, I'm dropping the 7, and really I could just pretty much ignore that. Equals 47 right now. I'm going to keep it just so we can see it. And then I got my constants 7 and 4 that I can combine. 7 plus 4 is 11. Okay, then I'm going to drop that's positive 12x's. And this equals 47. Okay, this should look pretty familiar to us because it's an equation, it's a type of equation that we've solved lots of these types of equations, okay? So that's what I'm going to do, and I want to isolate my x's, meaning these 12x's. I don't want this 11 added to it, which means I'm going to have to zero it out. So how do I zero out a positive 11? Minus 11. And the principles of equality, hopefully you remember, if you do it to one side here, you're going to have to do it to the other side. So I'm going to have to minus 11 on the right side as well. Now that's going to give us a 0. I don't like to show the 0 right there. I like it to be a phantom 0. So I put the 0 here. Again, I'm not circling those numbers, those 11s. I'm just showing that it became a 0. Then the 12x, that's positive 12x, it drops. It's 12x. And the reason why that green line is an arrow is because it drops the equal sign as well. 47 minus 11 would be 36. That's nice because that's going to give us a whole value for our x. Okay, the next thing here that I'm going to do, and yeah, that's going to bring down the equal sign again, is to divide both sides by the coefficient, which is 12. Why do we divide both sides by the coefficient? Because it gives us 1x. That's how our answers should look. There should be 1x's in the end. Well, then you got 36 divided by 12, which is 3. So right now we're saying x is 3. This should be the solution to the original equation, right? Now if we go back, not that I think anyone would want to, but you could go back to the original equation, which was 7 plus 4 times x, 3x plus 1. And whatever that is, it needs to equal 47, right? If this is to remain true, remember that's what an equal sign is. It's more of a question mark. Sometimes you use an equal sign and you find that it's false. Sometimes it's true. We hope that this is true if we replace the x with 3. So that's what I'm going to do. I'm going to go in here and replace the x with 3 that we think it is, and it should make the original equation a true statement. So I got a question mark over the equal sign, right? So this just becomes order of operations. You got 3 times 3 is 9, 9 plus 1 is 10. Then we got 7 plus 4 times 10, 4 times 10 is 40. 7 plus 40 is 47. Well, the original statement would have been 47 then equals 47. Well, last time I checked, that's true. And it is for now. So since it is true, I now know that 1x equals 3 is the actual solution to the equation. Remember, a solution to an equation is a value that you can replace the letter with that makes it true. It just made it true. Boom. Remember, the main difference between this problem, which is an equation, not an expression, is that it now has an equal sign. That's when we use principles of equality. If there is no equal sign, we're just looking to maybe distribute and then combine like terms. There's our objective. I can simplify expressions with distribution, which is multiplication, and combining like terms. And again, the whole idea with these two, which is a review, is that in the future when we see this with equations, that you can use these two principles or properties when solving equations.